Hello everyone. In this very short video, I just want to introduce Sympy. Python module stands for Symbolic Python. And this is going to help you with your final assignment in Math 266. So I will post this notebook in Canvas so you can take a look at this. So what you need to do is just import Sympy, and this line right I'm doing here, instead of deciding which particular modules and methods in Sympy I want to import, I'm saying from Sympy import start. So just import everything. And also these two lines right here will allow you to get some nice outputs. But now notice how we define a matrix in Sympy. Let me call the matrix MAT, matrix. Here we go. MAT is equal to matrix. You type in matrix, and then one way you can create a matrix is give the size of the matrix. Like if it's a 2 by 2, just type 2 by 2, and then just type what all the entries in the matrix are. And let's see if that works right there. All right. And somehow that cell got, here we go, try it again. And then let's take a look at that matrix. And notice a nice way that it's printed out. Yeah, that looks good. Okay, so now if you want to create a vector, it's just going to be done like this. It's a matrix, but the size is, let's say we want it to be a column vector, so the size is 2 by 1, and then let's give the entries. Let's make it 1, 1. Oh, I want to change that. Let me call that V for vector. Okay. And here we go. Let's take a look at it. There it is. Now, let's take that matrix and multiply it by the vector. And we get that 3, 4. Okay, so far so good. Now, the reason why we need to use Sympy is if your matrix has exact numbers, then when you do an operation, it's going to give you exact numbers. For example, if I take that matrix, I'm going to do the inverse. So I type dot inverse, open close parentheses. Notice that it's giving me the answers as rational numbers, as fractions. And this is what you're going to need when you enter your answers in MyMathLab. Now, if that matrix was originally defined, now if I come back up here and take that matrix and I put a decimal point somewhere, like at 1 point here, 1 point, see that? So we'll make a slight change there. Okay, see that? Now when you do ask for the inverse, it's going to give the answers using decimals. But if you give everything with whole numbers, that's what you will get. Okay, so now, so some of the other operations that we're going to do, we do matrix dot determinant. Yeah, there's the determinant of that matrix. I could do matrix, and I think I did inverse. Now, we want to multiply the matrices together times MAT. That should give me the identity matrix. Okay. Yep, that worked. Now, when you perform a method on an object like a matrix, if you move the cursor in between those parentheses right there like this and hit Shift-Tab, it's going to bring up a help menu to show you what that method does, okay, and what it returns. So let's look if we need to find the eigenvalues. Well, before we define eigenvalues, say I want to do the reduced row echelon form. Okay, this is something nice with Sympy. We didn't have this. Now, this not only gives you a reduced row echelon form for that particular matrix, it gives you this second piece of information here, which tells you where the pivots are. Now you might say, hey, suppose I just want to return a matrix. Well, you can see this is kind of like a list. So if you put this 0 here, so hey, just give me the first output, then that's going to give you that reduced row echelon form of that matrix. Other things you might want to do is matrix.eigen values. Now here, so notice again, we're getting the eigenvalues using the exact values instead of the decimal approximations. And this is what we're going to need for MyMathLab. But you say, hold on, what's going on here? Well, the first eigenvalue is 1 minus square root of 6. The second number tells you what the multiplicity of that eigenvalue is. Well, it has a multiplicity of 1. The second eigenvalue is 1 plus square root of 6. It has a multiplicity of 1. And finally, I think the last thing that we're going to need is Eigen Vectors. Okay. Now, again, if you have trouble interpreting an output, put the cursor inside here, hit Shift-Tab. And this will explain, say, hey, it computes the eigenvectors of the matrix. And then notice what the output is. Returns eigenvalue, multiplicity, eigenspace. All right? So notice what you get. When I ask for eigenvectors for that matrix, hey, can we write down what that matrix was again? This matrix right here, when I ask for the eigenvectors, here's the eigenvalue, multiplicity of 1. There's the eigenvector. Okay, there's the eigenvector. Let's see what happens if I do this here. Okay, that just gives you the first one. Just a second. Sorry about that. Okay, so you can zoom in. So there's your first eigenvector. Well, I think that so I'll post this on Canvas, and because you want to load these in, and you could use Sympy to help you so you can get answers for your questions for our last MyMathLab assignment, and you can enter them using exact inputs because that's what it requires. Thank you for listening.